Alright guys, let's do the covalent bonding, which you of course know many times we discuss between non-metals and between non-metals. Alright, so you have definitely non-metals here. So let's say if you can see this periodic table, this yellow patch including hydrogen, of course that's all non-metals. It means if we have, for example, chlorine. So if I say chlorine atom, you say the formula is equal to Cl only. But if I say chlorine molecule or chlorine gas, it is equal to Cl2. So that is Cl2 molecule over here. Now Cl2 means that we have two atoms of chlorine bonded together. So if I say, let's say this is chlorine, let me just make it black, and we have another chlorine, sorry, we have another chlorine like this, and here. So the chlorine, and we know in chlorine group number 7, and is having 7 electrons in the outermost shell. So what I do, I have 1, 2, 3, 4, 5, 6, and 7. And we have, for example, 1, 2, 3, 4, 5, 6, and 7. Now we need to make 8. We know this is chlorine, there's another chlorine. We need to make 8. So what I say in this case, we have sharing of electron, but sharing is the best practice. Sharing is caring, you know this thing. So what I will do, that's my first step. I've done it. I will draw this thing again. So just to save time, I just copy the same diagram. In fact, yes, I can copy one diagram and those over here and draw the second one exactly here like this. So we have got 1, 2, 3, 4, 5, 6, and the 7 here. And you see this place is being shared by one pair of electron. So one pair of electron means Cl dot n cross. This is a pair. So one pair shows, I think, is having single bond here. All right, so single bond. If we have two pairs of electron, that'll be double bond here, and three pairs of electron, we have triple bonds over here. So that's the thing we just do in covalent bonding. We have seen that thing, how we have arranged two non-metals together. Now if I go for another one, let's say I just go for um, another one which is called let's say O2, oxygen molecule. If we have oxygen molecule, it means that I'm talking about O2 here, O2. So we need to find O in the periodic table, and this O is here, group number 6. So it means, let's say, so it means 6 electron outermost shell. This time we have oxygen here. Let me take it green color, oxygen. So we have two atoms of oxygen becomes a molecule. So number of electrons for oxygen is in 6 groups. 1, 2, 3, 4, 5, 6, and then we have the other oxygen, which is 1, 2, 3, 4, 5, and 6. Both are oxygen, all right, and we need to make sure both are having 8. So what I can do best over here, I mean, it comes with a practice, otherwise keep practicing again and again. You have one oxygen here, and I will do what? I will take another oxygen and put it here. So I will do one thing. 1, 2, I just did not make with the dots. Okay, 3, 4, and 5, and 6. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. So now I've achieved both are having 8 electron in the outermost shell. And now we have, let's put a dot here. That structures like this. And we have O should be having a double bond between other oxygen molecules. So that's oxygen there. One thing is very interesting here. If we go for Lewis structure, which is very easy, if we can take off the whole circle and draw the whole thing without circle. I mean, I just told my time in the class, if it just the same structure without circle, that means your least structure. So if I, for example, take this, copy this one, same thing, I'm copying over here, 1, 2, and this is oxygen, and we have two pairs here. Let me use that dot here to make it more clarify, and one dot here, and then we have another O here, and then we have 1, 2. I think this O is quite far away, so I need to make it closer. So we have another O here, and this is 1, 2, and 3, 4, 5, 6, 7, 8. So if you draw exactly the same structure from here to there, and without any sort of circle, that calls we lose structure. But you understand, I think we have double bond between oxygen and oxygen. Quickly we do with that another one. Let's say we do two elements combined together. Let's say I'm talking about carbon dioxide. So let's just CO and 2 is carbon dioxide here. So we know carbon is 1, so I just take carbon 1. It's having 4 electrons in the outermost shell. So let's see, we have 1, 2, 3, and 4, and then we have 2. We have oxygen, so oxygen, we take 1 oxygen here, 1 oxygen here, because there are 2 oxygen. But exactly, an oxygen contains 6 electrons in the outermost shell. So this time I take dots here, 1, 2, 3, 4, 5, 6, and same thing here, 1, 2, 3, 4, 5, 6. Let me write down the name. This is, we have oxygen, this is carbon, and this is oxygen here. So we need to make sure all are having 8. Right now this one is 6, this one is 6, and this one is 4. So if we do what, we take this and replicate exactly same thing, same way, and I do the same thing here, saves time, and I put it here. And what I would do, because I have to remove a few dots anyway, I just take another circle and draw here, which should be green color here. All right, now I have to make 8, so we know this is carbon. I write carbon here. So I took 2 carbon here, this is here, and 2 carbon here. I draw it here in this area, and I just remove these 2 and put it here. And the same thing, I remove this 2 from here and put it here. If we count it now, 1, 2, or 3, 4, 5, 6, and now this is 6 here. So oxygen is having, so I just keep this thing over here, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and carbon is 1, 2, 3, 4, 5, 6, 7, 8. So it means what you can see here, we have got 1, 2, 3, 4, 5, 6, 7, 8. So consider this is available here, or you can make it more clear. And we have the circle intact as it is, and we still have 2 electrons here. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7. So all are happy face now, we can see, and having 8 electrons in the outermost shell. And that means now you need to consider that carbon is having a pair with oxygen, pair of electrons. Same thing with the other one with oxygen. It means that thing we have not single bond, we have a double bond between carbon and oxygen. And if you more practice further, let's say if you do practice with the nitrogen and 2, and you will realize, I think nitrogen will have 3 pairs of electron between them. Just practice it, find out. Let's say methane, the CH4, and this is a single bond, but you need to just make sure how we have carbon 1 and we have 4 hydrogen atoms. They are joined together making covalent compounds, and they are having a low melting and boiling point. Of course, they do not conduct electricity, and they do not dissolve in water. And ionic compound, more, I think video I just didn't mention that. I think ionic compounds, of course, they dissolve in water. They they conduct electric current when they are in aqueous solution and when they are in molten solution also. So these are the properties different between ionic and covalent compound. Hopefully you guys do well. Thank you very much.